We're going to start by getting our Bunsen burner lit. We're going to do that by opening the valve on the side of the hood and then the valve at the bottom of the Bunsen burner until we hear gas flowing, at which point we're going to light it with our flint light, or as you can see me here, failing to light it and then getting it to light. The burner flame is tough to see normally, and it's even tougher to see on cameras, so a lot of this experiment is going to be done with the light off. That way you guys can better see the flame. Here I'm just adjusting it so that the top of the flame is going to be hitting the bottom of the triangle where our crucible is going to go. Once our flame height is good, we're going to preheat our crucible. This allows us to remove any impurities from previous runs. I'm grabbing the crucible by the edge here. It's a little more stable to grab it this way as opposed to the little indent in the tongs. You guys are going to see here too that I'm going to put the lid on the crucible. You really don't have to for this step. I just wanted you guys to better see how this lid's going to sit there for most of the experiment. We don't want it fully covering it because then the magnesium won't react, and we don't want it fully open because that is another issue we'll get to later. We're going to let this heat for about 5 minutes and then cool down for the same amount of time before weighing. Remember, we can't weigh things warm, it'll give us a false reading. So this was the mass of the empty crucible to start, so that's going to be your first data point. At the same time, we can get our magnesium ready. So you guys can see here, or at least attempt to see here, there's a bit of tarnish on this magnesium strip, so we're going to have to remove that in order for it to react fully. We're just going to do this by running some sandpaper on it while not trying to touch it with our hands so we don't get any oil on there. Afterwards, we're just going to coil it and put it into the crucible. So you guys can see here, this is what this is going to look like. After that, we're going to weigh it, and we're going to get our massive crucible with magnesium in it. So if you guys take this mass and then subtract it from the mass we got earlier, that'll give you the mass of the starting magnesium. Here, I'm just making sure that the lid is on properly. Again, we don't want it too far open, and we don't want it fully closed, so it should stay like this. So now that we're happy with that, we can get the Bunsen burner relit. So again, same thing as last time, turning the gas on from the side of the hood, and then using the flint light to light it. Again, I'm going to shut the lights off just so we can better see the flame. And here I'm just going to very subtly adjust the flame height. We want the inner cone of the flame just to cup the bottom of the crucible. This is going to help us heat the magnesium properly. As this heats up, you guys are going to start to see the inside of it glow. That's fine. That's just the magnesium reacting with the oxygen. This is what we want. There's a difference between that and magnesium igniting. So a low orange glow is good in this case. A bright yellow to white flame is bad. You guys can see here that the clay triangle along with the bottom of the crucible are starting to glow as well. That's a good sign that we're heating it properly, and you guys can now see the orange glow inside the crucible. This is our magnesium reacting. So magnesium is going to react with oxygen, and it's going to produce the magnesium oxide. It's important here to really control the amount of heat that the crucible is getting at this point, because if we heat this too rapidly, even with the cover on properly, we can't ignite the magnesium. So you're going to see me a couple times go back and forth just to make sure that the crucible is being heated properly. If you heat it too aggressively, you will ignite the magnesium. Or if the cover is not on properly, you would ignite the magnesium. If that would happen in lab, all you would do is slide the cover on, shut the Bunsen burner off, and wait a couple minutes until the ignition stopped. If you open the cover and it reignites, you just cover it again and keep doing that until it stops. So I've mentioned a couple times that you don't want the magnesium to ignite, so I think it's only fair that I show you guys what the ignition actually looks like. So this is a little bit dangerous. Magnesium does burn very brightly, so you guys are going to see, please do not attempt, but this is just for demonstration. What you guys are going to see is this is going to be a very bright yellow to white, and it's going to look very different from our magnesium reacting from earlier. Again, I'm accomplishing this by heating it both vigorously and having the cover off. You guys can see I'm holding the cover right next to it just so I can cap it when it does finally ignite. And you guys can see here that it is finally igniting. You do have that bright yellow, and if we let this sit for a while, you're going to see it become a little white. and that's about as far as I wanted to take it before it really started reacting, because again, this is a little dangerous to do. That was, by the way, done with a different piece of magnesium, so we didn't mess with our results. So this is back to the original piece of magnesium, and we're just going to fast forward through this because we have to heat this for about 10 minutes, and there's no need for you guys to watch 10 minutes of a Bunsen burner just burning, so we're just going to fast forward through as much of this as possible. And then when we finally hit the 10 minutes, we're going to take it off the heat and let it cool a bit before we move on to our next step. Once the magnesium cools, we're going to break up any of the big chunks of magnesium oxide and crude product that form. This is what our crude product looks like. We do have to do one more step before we finish this, though. So we have to add a couple drops of distilled water. And this is because we didn't just form magnesium oxide, we also formed a byproduct of magnesium nitride. So this was reacting with air, and remember that air is mainly composed out of nitrogen. So we have two reactions happening, primarily the magnesium reacting with the oxygen, but we also have magnesium reacting with the nitrogen. And when that happens, we have magnesium reacting with nitrogen, we get magnesium nitride, which is also a solid, unfortunately. But thankfully for us, by adding water to it, we can have the magnesium nitride further react. And that's going to be magnesium nitride reacting with the water we just added. It's going to form magnesium hydroxide and ammonia gas. The ammonia gas is just going to flow off, and it's going to leave us with magnesium hydroxide. Thankfully, again, magnesium hydroxide, when heated, will also decompose. And when it decomposes, again, thankfully for us, we form magnesium oxide, which is the product we were after at the beginning, and water gas that's just going to flow off. We're going to heat this in the same way we heated it earlier, with having the crucible just at the top of the inner cone of the flame, and we're going to heat this for about 5 minutes. Again, just fast forwarding through here so we don't have to sit around for 5 minutes. We're finally done. We're going to, again, shut the gas off, let this cool a little bit on the triangle, and then let it cool a little further before weighing to get our final mass. Remember, we want this to cool first so we can get an accurate reading for the mass. So once it cooled, this was the mass of the magnesium oxide with the crucible. And if we did our reaction right, the difference in mass from this and the beginning is solely the result of the oxygen reacting with the magnesium to form magnesium oxide. So using that information, we can actually tell how many moles of oxygen were used. And using that, we can solve for our empirical formula for magnesium oxide.